Hello guys, this is Dushan Desu on behalf of LPU AWS Cloud Community. In this video, we will be discussing about AWS Elastic Load Balancer. Before diving into the demo of load balancing, let me brief you about what actually is Elastic Load Balancer. Elastic Load Balancer automatically distributes the incoming traffic across multiple targets like your EC2 instances, containers, and IP addresses in one or more availability zones. So basically how this function is that it constantly monitors the health of its registered targets. If it finds any of the unhealthy target, like your target resource may get down due to any of the reasons, then it restricts the traffic to it and routes the traffic only to the healthy targets. Coming to the benefits of load balancer, as I said, a load balancer distributes the workload. That is, it distributes the incoming traffic across various compute resources, like your virtual servers. So, using this helps in increasing the availability and fault tolerance of your application. To explain this in a better way, let's consider this example. Suppose there is a stock market broker who is a client of AWS. So what he basically does is that he adds more number of instances before 9 a.m. because he knew that there will be huge traffic coming into his servers during the market hours. So what he is doing over here basically is that he is scaling up his resources in order to manage his application. He also knew that there will be less traffic coming into his application after market hours and as well as in weekends. So then he cut off his instances. The use of load balancer comes when it needs to distribute the workload across multiple compute resources. Even when he wants to scale up or down his compute resources, he need not disturb the entire flow of requests of his application. He can easily do that with the help of his load balancer. Coming to the features of load balancing, the Elastic Load Balancer supports three types of load balancers: the application load balancer, the network load balancer, and the classic load balancer. For explaining about these load balancers and illustrating the demo and setup of these load balancers, I will be taking you to the AWS Management Console. So guys, this is my AWS Management Console, and now for load balancing, I will be going into EC2 service. This is how the EC2 dashboard looks like. Now if we scroll down, under load balancing section, there is a service called load balancers. If I click on that, here it is displaying that I don't have any load balancers in this region. Now I'm going to create one. As I said, the Elastic Load Balancing supports three types of load balancers: the application load balancer, the network load balancer, and the classic load balancer. And based upon this our requirement, we need to choose the load balancers. First, suppose if we need an application load balancer when we require the flexible feature set for our web applications with HTTP and HTTPS traffic. Operating this application load balancer operates at the request level. That is, it operates at layer 7 of the OSI model. It distributes the traffic based on the information inside the HTTP header or the path, that is the content of the URL. Now, we need to choose our network load balancer when we require ultra high performance or we need a support for UDP or static IP addresses for our application. It operates at connection level. The network load balancer distributes traffic based on layer 4. The distribution is based on various network variables like the IP addresses or the destination ports. The network load balancer is capable of handling millions of requests per second securely while maintaining ultra low latencies. So if we have this requirement, then we can go ahead with network load balancer. Then comes the classic load balancer. This is the previous generation load balancer. It was the first load balancer that AWS introduced in 2009. These days, the usage of classic load balancer is comparatively less than that of application load balancer and network load balancer. We can use this if we have an application running in EC2 classic network. It works on both layer 4 and layer 7. We can say that this classic load balancer is a connection based load balancer. Means it just forwards the request it got without looking what exactly those requests. Now I will be showing how to create a classic load balancer. For this, I have already created two instances. If you guys don't know how to create an instance, we already have a video in our channel on EC2 instance. Please go through that video. Under the name of load balancer, I'm gonna give my load balancer name as demo-CLB and I'm gonna create it under my default VPC. And coming to listener configuration, here it is configured in such a way that if there is any HTTP request on port 80 for the load balancer, then it sends it to the instance on the port 80 using HTTP. Next, it is assigning security groups. We need to assign some security groups so that we can allow inbound traffic to the ports. I already have a security group named web access which enables SSH, HTTP and HTTPS. So this is open for the port 80 and 443 which are for basically HTTP and HTTPS. So I'm assigning this security group to our classic load balancer. Next, for now I'm not using any secure listener, so I'm clicking on next. Next it is configuring health check. As I already said, elastic load balancing automatically checks the health of EC2 instances. If it found any of the unhealthy instance, that it immediately routes the traffic to healthy instance. I'm gonna leave the ping protocol and ping port the same as HTTP and 80 and the ping path is /index.html. Basically this index.html file is under the default Apache server directory that I have created when creating the instance. I'm gonna leave the advanced details as it is. Next, we need to add the EC2 instances to our load balancer. These are the instances that I have created. So I'm gonna add these to our load balancer and I'm gonna leave this as enable cross zone load balancing. What this basically means is each load balancer node of the classic load balancer distributes evenly across the registered instances in all these enabled availability zones. I am also leaving enable connection training and I am setting for this as default as 300 seconds. Here we are specifying that for this 300 seconds, it is the maximum time for the load balancer to keep connections alive before reporting the instances as deregistered. Next is adding tags. I'm gonna give the name tag and name it as classic load balancer CLB and click on review and create and click on create. So we have successfully created our classic load balancer. We will be checking on that. Now it takes time to activate. Until then we will be checking what is there in our instances. See, these are the instances that I have created. If we gonna and check the public IP address of first instance, it is displaying AWS Cloud Community LPU. The same we will be doing on the second. Take the public IP address. Okay. Welcome to your YouTube channel. So the first instance contains AWS Cloud Community LPU and the second instance contains welcome to our YouTube channel. So I want this load to be balanced on both the instances. So I am using this classic load balancer. Now we need to get either welcome to your YouTube channel or AWS Cloud Community. If we click on the DNS of our load balancing. Here it is our this is the DNS name for our load balancer. Copy it and paste it in the browser. See, it is now displaying welcome to our YouTube channel. If I refresh, now see it's displaying AWS Cloud Community LPU. So what is happening over here is it is evenly distributing the load for the first instance as well as the second instance. This is the main use of the classic load balancer. But the main disadvantage of using the classic load balancer is that it does not support path-based routing or port-based routing. For that, we need to use either application load balancer or network load balancer. Now I'm going to show how to create application load balancer. For that, I need to create instances. I will be stopping these two instances first. And I'm gonna launch another two instances. I'm gonna use Amazon Linux 2 AMI. Select. Next, under user data, I have a script file which I will be adding. Here the first line represents the shebang, means we are letting our kernel know that we are using the bin bash as our interpreter. Next, we are switching into root user account and installing our Apache server HTTPD. And we are going to start this HTTPD server and make it enable so that it will be persistent even after reboot. Next, add storage, leave it as it is, add tags. Under name tag, I'm gonna name it as server 1. Next, configuring security groups. I'm gonna assign this existing security group which is open for port 80 and 443 and click on review and launch. And launch our instance. It is asking for the key pair. I will be proceeding without any key pair and launch the instance. Our instance was launching. If we click on view, here the instance state is showing it as pending. Until it becomes active, we will be creating another instance, the same for application load balancer. And here under user data, I'm gonna add this another script file. And add storage, add tags. Under name tag, I am going to name it as server 2. Configure security group, assigning the web access security group, review and launch. Proceed without key pair. Launch the instance. Now check. Here our server 1, it is in running state, but the status is initializing. Let us wait. Now if we can see both the servers were in running state. Let me open the IPv4 address of this first server and copy it. So it is displaying AWS Cloud Community LPU. If I go under block directory, so it is displaying this is our block page. All this is pre-configured when we are loading our user data, when we are launching our EC2 instances. And if we check on the server 2, so it is displaying our YouTube channel. Now what I want is it should evenly distribute the traffic. If the path contains the block if the path contains block, then it should route the traffic to the block first instance, and if the path contains YouTube, then it should route the traffic into the second instance. For that, I will be creating an application load balancer. Before creating the application load balancer, I will be creating the target group. So what basically this target group is that this target group contains some targets which are registered. So if we configure any listener checks that we will be creating after creating the load balancer, then if we configure that listener check and give the condition, if the condition is met, then the traffic will be routed into the targets. For that we will be creating target group. My target group is of instance. I'm giving the target group name as TG ALB and leaving this everything as it is. And for health check, I will be providing index.html. Click on next. I'm gonna add this target group, the server one, as in my target group. Click on include as pending. Create target group. Now for server 2, I will be creating another target group. This is TG2 ALB. Leave everything same and same index.html for health check. Click on next and add server 2 this time. Include as pending. Create target group. Now if you can see, we have two target groups for two instances, target group ALB and target group 2 ALB. Now we will be creating our load balancer. Create load balancer and create the application load balancer. The first step is configuring our load balancer. We need to give our name. We will be giving demo ALB and the scheme is internet facing and the listener will be HTTP on the port 80. I'm gonna create it in my default VPC and add this at least 2. We should add these availability zones. I'm gonna add 3. Next, configure our security servers, server groups. For this video, I will be not using any secure listener. Next, configuring security groups. I'm assigning this web access security group. Configure routing. And we need to select this target group. I will be selecting the existing target group that I have created. We can select any of the target group. I am selecting target group ALB and leave everything as default. We need to register targets. Next, review and create. We have successfully created our application load balancer now. Now if you can see, our application load balancer is in provisioning state. It takes time to convert into active state. Until then, we will be adding our listeners. We will be editing the listener rule. See, here there is an option called edit rules. Click on this plus button, insert rule. Now what we want, if our path contains the value, if it contains block, then the action is we need to forward it to target group ALB, which contains the instance of server 1. Click on save and we need to add in the next rule the same. If our path contains YouTube, then we need to forward it to second target group, which contains the server 2 as the instance. And click on save. The new rules were created and added successfully. Let us check whether our ALB is active or not. It is still in the provisioning state. Let us wait for a minute. Now if we see that our ALB is in active state. So we will be taking the DNS name and paste it in the browser. Suppose our path contains YouTube. Then it will automatically redirecting to the second server. Or if our path contains blog in it, it will be redirecting to the first server. So what is happening here is it is distributing the load based upon the path. Here the main usage of application load balancer comes. We can't do this path based routing in classic load balancer. This is the benefit of using application load balancer over classic load balancer. Now I will be demonstrating on how to create a network load balancer. For that I will be requiring another two instances. So I will stop these two. Stop. Successfully stopped. I'm gonna launch instances. Click on select. Next. Here in the network load balancer, we will be working on ports. So if we communicate through one port, then it should navigate to one instance, and if we communicate to other port, then it should route the traffic to that instance. For that, I will be using this script file. Add storage, add tag. I'm gonna name it as instance 1 NLB. Configuring security groups. Let it be open for port protocol HTTP under port 80. Review and launch. Launch it. I'm gonna launch it with my existing key pair. Launch the instance. In the same way, we will be launching another instance, but this instance should be open to the other port other than port 80. So let us use this script file, add storage, add tag, and name it as, suppose, instance 2 NLB. Configuring security groups. Here we will be opening port 8080 so that all the requests coming from port 8080 should be routed to this target, means this instance. Review and launch. And launch. I'm gonna launch it with my existing key pair only. Let us verify. See, our first instance is in running. Let us check the IP address. See, it is displaying please give your feedback. Now let us check our instance 2. It is also running, but it should be giving us an error. Let us wait for a minute. See, it gave error because we didn't open our traffic through port 80, because by default it is port 80. Now let us check for port 8080. Again it will give the error because the default port which the instance will be listening will be port 80. We need to change that in the configuration file. So let's connect to the instance. I'm gonna connect it with my putty, adding my private key. And the username is EC2 user. at the rate, copy the DNS, public DNS, and paste it here. Click on open. Yes. And we are logged into our instance. Log into the root user and go to the place where the configuration file of HTTPD will be stored, and if we list the files, see there is a configuration file named httpd.conf. We need to edit that file. Maximizing my screen. See here it is listening on port 80, but what we need to add port 8080 here. Let me bring my cursor here and add port 8080. Save it and restart the HTTPD server using systemctl. Done. Now let us check our instance. See, now the second instance with the port 8080, it is running and giving us thank you for your feedback. Now we need to configure this by using the network load balancer. So let me create. Before that, I will be creating the target groups just like application load balancer. Click on create target group. I'm gonna create the instance as a target. Name it as target group 1 for network load balancer, and the protocol is TCP over port 80. Click on next. Adding my first instance which is open for port 80. Create target group. So a target group for NLB is created. We will be creating the second target group. Target group 2 NLB, and this is open for port 8080, and rest leave it as it is. Click on next. Adding my second instance which is open for port 8080 in the target group 2, and click on create target group 2. Now if you can see that we have created two target groups for our network load balancer. Now I'm going to create the network load balancer. Click on load balancer. Creating our network load balancer. I'm gonna name it as demo NLB and make it available for 3 available zones. And now configuring the listener. The first listener, it is default under TCP 80. If we are getting traffic through this port 80, then we need to forward it to the first instance target group. I am also adding another listener. If the traffic is coming from port 8080, then I'm gonna forward it to the second target group and click on create load balancer. View load balancer. Now it is in provisioning state. It takes time to become into active state. Now if we can see that our network load balancer is in active state, let us copy the DNS name, paste it over here. By default it will be taking port 80. So it is displaying please give your feedback if we are accessing through port 80. So if we are connecting through port 8080, then it is showing thank you for your feedback. So what is happening over here is it is it is working based on port based routing. If we are accessing our instance, accessing our application using port 80, then it is routing our traffic to one instance, and if we are using port 8080, then it is routing it to the another instance. This is the use of network load balancer. So I hope you all have understood about all the three load balancers. Thank you. Have a nice day.